All right, so in the last video we talked about if we had two matrices A and B and we multiplied them. So if A is an m by n and B is an n by r matrix, when we multiply it, the result is going to be m by r. So the outside numbers on our dimensions. And so that's what needs to match up is the inside. So the inside is the n and the n. So let's write this out. If we have matrix A and matrix B, and we know that matrix A is an m by n matrix, and matrix B is an n by r matrix, we need the inside dimensions here to match. If the inside dimensions don't match, then we cannot multiply our matrices together. Also, the result of multiplying our matrices together are going to be the outside dimensions, m by r. All right, so let's see how this looks in practice. All right, so let's say we have one matrix multiplied by another. All right, so here is how it works. It's kind of like sleight of hand kind of thing. We're going to go across with the first matrix and down with the second matrix. That is how our multiplication is going to go. So for example, first matrix, second matrix, let's say we have a row somewhere in the middle in the first matrix and call this the ith row. And then maybe we have a column in the second matrix. We're going to call it the jth column. All right, and so as we multiply, we're going to do this motion of going across one and down the other. And they are going to overlap at some particular place. All right, so the result of multiplying these matrices together, so when you use the ith row and the jth column, our result gives us this one little component. And this component is going to be in the ith row and the jth column. And this will make more sense when we actually do some examples with numbers. But just remember this motion, across and down, across and down. Okay. All right. Let's do some concrete examples. All right, first example, let's multiply this matrix down the columns. I got 1, -2, 3, and 1, 0, 2. Second matrix, down the columns, I got 1, 2, 3, -1, 0, 1. Okay, remember I said dimensions are very, very important. Okay, so this is a 3 by 2 matrix. This is a 2 by 3 matrix. Notice how the inside numbers match up, and we see that our result should be a 3 by 3 matrix. All right, so let's take a look at how this works. So I know my result is a 3 by 3, so how do we do this? Well, we are going to go across the first matrix, down the second. So we're going to look at 1 times 1 which is 1, plus 1 times 2. And this is where we get our first component. Okay. If we want to get this component here, we're going to use the first row of the first matrix and the second column of the second matrix. So across and down. So 3 times 1 is 3. 1 times -1 is -1. So that's that component. All right, if I want this one here, I need to use the first row, last column. 0 and 1. Okay. So as you can see, this is a very long, tedious process. All right, now we're going to move on to the second row of our first matrix to get this position here. Second row, first column, -2, 0. All right, if I want this one, second row, second column, this is -6, 0. All right, last part, 0, 0. And then finally the last row, to get this component down here, I'm going to use the bottom row of the first matrix, the first column of the second. 3, 4. -9, -2. And then 0, 2. And as you get better at this, you'll probably do this addition in your head, but you do not need to. All right, and now you just do the addition. All right, and so the result is a 3 by 3 matrix. Okay, so in your previous sections, you've learned about transformations, right? Linear transformations. So actually, when we are doing matrix multiplication, it's just a composition of linear transformations, right? So this first part, this first matrix, is actually going to be the transformation that takes things from R2 to R3. And then the second matrix is the thing that takes things from R3 to R2. All right, and so remember, transformations, compositions, they go backwards. So you're going to take something in, we're going to start here. We're going to take something in R3. It's going to go to R2, and then we can put it in here to R3. And that result is what we get by multiplying a vector times this resulting matrix.